Okay, so continuing on from what we've been talking about the last couple of days, we did Rutherford's model yesterday. We talked about it, but then when I asked you guys to draw a picture of Rutherford's model, we got a little confused. So let's just try to kind of review what Rutherford's model looked like. What did he say? From his gold foil experiment, he was able to make some conclusions, and so we could kind of figure out what his model looks like. Anyone want to take a guess? What goes in the middle of an atom? The nucleus. Ta-da. What is in the nucleus?
Oh, sweet. Electrons.
Not electrons.
Protons.
Protons. And anyone? Neutrons. And what did he say about electrons? Where did he say electrons were?
The outside.
They were on the outside in something called an electron cloud. So this was Rutherford's nuclear model, right? Was he very specific about where the electrons were? No. Okay. All right. So continuing on from that, let's talk about isotopes today. So, first of all, an atomic number. Atoms, we learned yesterday, are composed of protons, neutrons, and electrons, but they are all identical. Every single proton is exactly the same as every other proton. Every single neutron is exactly the same as every other neutron, so on and so forth. Protons are protons are proton. So, if all atoms are made out of, if all elements are made out of the same materials, why is it that they are different? Does anyone know? If they're all made out of protons, neutrons, and electrons, what makes them different? The number of them, right? So they have more protons, less protons, so on and so forth. And specifically, protons. Protons are what identify elements as what they are. So if I tell you something has eight protons, I can look up on the periodic table and tell you that it's oxygen. If I tell you something has 9 electrons, can I look that up on the periodic table? Anyone? No. The only thing that identifies an element is your number of protons. Everything else can vary. Protons are always the same. This is called the atomic number. The atomic number of an element is the number of protons in the nucleus. And for right now, the number of protons in an atom is equal to the number of electrons, but that's going to change here in a week or so don't get stuck on that. So, if we look at the periodic table, which number is the atomic number? There's lots of numbers up there. Which one's the atomic number? Someone look up there. Tell me which one the atomic number is. The one on top of the symbol, so on the one in the back, it's the blue numbers. Up here on this one, it's the green numbers. The atomic number is not always going to necessarily be on top of the symbol. Sometimes it's on the bottom. Every periodic table is a little bit differently. So you need to be able to tell which one's the atomic number. So how is the atomic number different from that other number up there? It is not a decimal. So your atomic number is always a whole number. Okay, so let's just kind of do a little practice. So if I tell you the atomic number of carbon is 6, how many protons does it have? 6. If I tell you the atomic number of phosphorus is 15, how many protons does it have? 15. If the atomic number of gold is 79, how many protons does it have? It has 79. So it doesn't really matter what element I give you. Every single atomic number is going to match the number of protons, so we should be able to get into the habit of that. The next thing we're going to talk about is something called a mass number. And again, I kind of try to give you guys hints as to where people have messed up in the past. And this is one of those things that we kind of sleep when I'm explaining it. But the mass number and the atomic mass are two completely different things. So right now we're going to talk about the mass number. Mass numbers are often associated with isotopes. To figure out your mass number, you have to add your protons plus your neutrons. Protons plus neutrons equal your mass number. So that is always going to be a whole number. But look up at the periodic table. That red number up there is a mass, but do you think it's our mass number? No. Why is that not our mass number? Nope. Why is that number up there not a mass number? It's a decimal. Mass numbers have to be whole numbers. Those masses up there are actually averages. So your mass number, if you want to take that number and get the mass number, that's fine, but you have to round it. Mass numbers have to be a whole number. So let's see if we can finish this table. There's a lot of blanks in this table, right? So let's see if we can finish it together. So if we look at the first row, we're dealing with oxygen. Do I know what the proton, do I know how many protons oxygen has? Why does it have 8? Because it has an atomic number of 8. Its atomic number is 8, so it has 8 protons. Okay, this is a neutral atom, which means our positives and negatives have to be equal. So how many electrons do we have? 8. Okay, next we need to figure out its mass numbers. Mass numbers are protons plus neutrons. So what is 8 plus 10? 18. Now, if we look up at the periodic table on the wall, what is the mass listed on the wall? 15.9994, which is 16, right? Is 16 and 18 the same thing? No, so we have a different form of oxygen here, don't we? Okay, so the way you can represent that we're dealing with a different form of oxygen is to put an 18 after oxygen. So this is oxygen 18. That 18 is telling me my mass number is 18, not 16. What's listed in the periodic table. So let's see if we can do the second row. It gives us 2 pieces of information. Our protons are 33. Our neutrons are 42. Using my proton, what can I look up on the periodic table? The name of the element. 33 is our atomic number. So you look up 33 on the periodic table, so we know this is what element? Arsenic. Okay, then this is a neutral atom, so how many electrons? 33. Then can we figure out our mass number? How do we figure out our mass number? Protons plus neutrons, so 33 plus 42 gives you 75. How can I name this arsenic now? Arsenic 75. Okay. Let's do the last row now. We have 15 protons, and it tells us that we have blank 31. What is that blank 31? What is that 31 telling us? The protons plus neutrons equal 31, so our mass number is 31. From that, we can then name it. So what element are we dealing with protons of 15? Phosphorus. We have 15 protons. How many electrons do we probably have? 15. And then this time around, we're not adding to figure out neutrons. We have to subtract. So we're going to do 31 minus 15 to give us how many neutrons? 16. Okay, there's actually another way you can write this information. So we can always call it oxygen 18. And I'm telling you, I'm dealing with the version of oxygen with a mass number of 18. But there's a new way that you can also write it. You can write it with your mass number written as the superscript, your atomic number written as your subscript, and your element symbol as the main part of the name. So let's do a few practices with this way. Let's see if we can do it this way. So let's look at bromine. Okay, Br is bromine. What is the 80 in that symbol? The mass number. What's the 35? Our atomic number. So A, how many protons do we have? 35. Your atomic number and your protons are equal, right? Mm-hmm. B, how many neutrons? How do I figure that out? You subtract your mass number by 35. So 80 minus 35 gives us 45. How many electrons do I have? 35, because our electrons and protons are equal now. What about our atomic number and our mass number? 80. So let's see if we can write one of these all by ourselves. So I have given you a word problem. We're not very good with word problems, so let's try to convert it into a symbol to try to make it easy on us. So first, right off the bat, it says an element has an atomic number of 34. In a symbol, where does the atomic number go? It's the subscript, right? The atomic number is written as the subscript, so it's going to go on the bottom. It then says we have a mass number of 78. Where do we write mass numbers? Top. Then I need to figure out what element I'm dealing with. Am I going to look up 78 or 34? 34. If we look at the periodic table, 34 is Se. So now we have our complete symbol, right? So now let's see if we can answer these questions. A says, how many protons do we have? 34. Our protons are equal to our atomic number, right? B says, how many neutrons do we have? How do we figure out neutrons? I'm going to do 78 minus 34. So we're going to get 44. Why I couldn't do that in my head, I have no idea. Then we're going to try to figure out the number of electrons. Electrons are usually equal to protons. So how many do we have? 34. And then looky there, we already have D done. We already wrote our complete symbol. Okay. Let's do another practice. Okay, this time it says if an element has 91 protons and 140 neutrons, what is the... So right off the bat, I'm going to go ahead and make the symbol. It makes everything a whole lot easier, right? So it has 91 protons. Well, we can't put protons on our symbol. We can put atomic number, though, right? So if we have 91 protons, our atomic number is 91. Is that the subscript or the superscript? Subscript. Okay, it then says that we have 140 neutrons. Is that my other number? No. What goes on top of my atomic number? My mass number. So my mass number is what plus what? Protons plus neutrons. So if you take 90 plus 140, you get 1, 3, 2, right? 231. Okay, now we need to figure out what element we're dealing with. So what do I look up on the periodic table? 231 or 91? 91. What element is 91? Yay, we already did D. Okay, so A says what is the atomic number? 91. B says what is the mass number? C says what is the number of electrons? Number of electrons is 91. Are we getting the hang of this? Okay, I think there's one more example that we're going to do. Okay, this one says an element has 78 electrons and 117 neutrons. What is the blah, 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 blah. So, 78 electrons. Is that telling me any information I can use on my symbol? No. But if we have 78 electrons, how many C protons do we have? We have 78, right? If we have 78 electrons, we probably have 78 protons. If we have 78 protons, what's our atomic number? 78. So is 78 going to be my subscript or my superscript? Subscript. It then says that we have 117 neutrons. Is that my mass number? No, but to figure out my mass number, we're going to take protons plus neutrons. We know we have 78 protons, and we know we have 117 neutrons, so it's going to be 195. Where do I put my mass number now? It's a superscript, so it's going to go on top of the 78. Now I can look up my symbol. Do I look up 178 or do I look up 195? 78, who's 78? PT. And then, we've already answered most of our questions, right? We've already done D. We've already figured out protons. We've already figured out the mass number. What's the atomic number? 78. Okay, so doing all of this, we are practicing how to do isotopes. So, do you remember yesterday or the day before when we were talking about Dalton and the first part of his theory said atoms are indivisible? Didn't we prove him wrong?
Yeah.
Atoms are divisible. They can be broken down into what? Electrons, protons, and neutrons. Well, the second part of his theory said all atoms of one element are identical. Do you think that's a true statement? No. Okay, he was wrong in the second part of his theory too. Atoms of the same element can have different numbers of neutrons. Every single atom of oxygen will always have 8 protons, but it is not going to always have the same number of neutrons. So if you don't have the same number of neutrons, what's going to change? Your mass number. Okay? When you have a different mass number, we call these guys isotopes. So isotopes are elements that have a different mass number because they have a different number of neutrons. Okay, Frederick Soddy was the one who proposed this idea in 1912 in the same time frame as the Titanic. He said that isotopes are atoms of the same element, so they're identical except for the fact that they have a different mass. The reason they have a different mass is because they have a different number of neutrons, and this actually won him the Nobel Prize in 1921. So, if isotopes are identical, they have the same properties, they have the same number of protons, they probably have the same number of electrons. The only thing that's different is the neutrons. We have to come up with a way to name them, right? Because if there's different forms of elements, but we call them all the same name, how are we going to differentiate them, right? So all we have to do to name an isotope is we put their mass number after the element. Okay, so for instance, carbon-12. We are dealing with the carbon isotope that has a mass number of 12. So it has 6 protons and 6 neutrons. However, carbon-14 also exists. Is it still carbon? Does it still act as carbon? The only difference between carbon-14 and carbon-12 is what? Different mass number because they have different... They have a different number of neutrons. So carbon-14 has 2 additional neutrons that carbon-12 does not have. Okay? The next one is uranium-235. Uranium-235 is an isotope used in nuclear power plants often. I want you guys to look up there. What uranium exists on the periodic table? What's the mass of uranium? Anyone read it? It's kind of hard. Uranium's number 92. It's at the bottom. Okay, the one on the periodic table is uranium-238. This is uranium-235. Those numbers up there are averages. So which do you think is more common? Uranium-238 or uranium-235? Right, so we are dealing with the less common form of uranium. Okay, what's the difference between uranium-238 and uranium-235? 3 things. They have 3 different neutrons, right? So uranium-235 is missing 3 neutrons. So, what I want you to do now is on my website, I have given you your homework. So if you go to my website and if you click on I'm going to start trying to put the homework over here in the homework section. That way it's a little bit easier to find for those of you who have been absent. And I have titled it 4.3 Isotope Practice. And if you notice, it's due on September 30th, which is Monday. So if you click on that, it will give you the homework. There is, I think, 7 questions. Where do you think you should write the answers to? In your notebook. You should probably give it a title. What do you think you should title your homework? 4.3 Isotope Practice. That way you can find it on your notebook quiz day. You should have plenty of time to get this done in class. Whatever time is left over, I want you guys to work on finishing your Foursquare because Monday I'm actually going to grade your Foursquare, so it needs to be done on Monday. Okay?
Yeah, we finished our